cross-sectional survey looks at a particular point in time. That's the key point. They are usually inexpensive and easy to conduct. They are useful for establishing preliminary evidence in planning for future advanced studies. So you can actually use data obtained from this study as input for future studies. Key characteristics of the cross-sectional, it looks and analyzes data such as age, income, health, status at a specified point in time. So that keyword keeps coming up at a point in time. It's more of a snapshot. It can be descriptive or analytical, can be used to describe a population characteristics or examine associations between variables. So it looks at it's usually population-based. The survey frequently uses a representative sample. It's non-experimental. So what it means here is that the researcher does not have to intervene or do anything or to give the study subjects any kind of medication or any placebos or to expose them to any kind of harm. We are just looking at them as they are in their population. Okay. Types of cross-sectional. So there are different types of cross-sectional. So cross-sectional studies can be divided into descriptive or analytical, depending on whether the outcome variable is assessed for potential associations with exposure or risk factors. So if we look at the descriptive cross-sectional study, it is an observational research design that provides a snapshot of a population at a single point in time. Unlike analytical designs, its primary goal is to describe the status or prevalence of a specific characteristic. If we look at the analytical cross-sectional, it examines relationships between variables. So if we look here, the first one was trying to describe what is happening in a population, but the second one here is trying to link relationships or correlations. Unlike descriptive studies that only aim to find the prevalence of a condition, analytical studies seek to test the hypothesis by examining the association of a relationship between the variables. So as with any study, the cross-sectional comes with its own advantages and disadvantages. I'll just touch on a few. Most of it will just share the slide later in the interest of time, but they are quick, efficient, and cost-effective. Because remember, we are just looking at a particular point in time. We are not going backwards. We are not going forwards. We are not looking into the future or track the people. We are just looking at them at that particular point in time. So this can be done in a short period of time, and there's no follow-ups. They are useful for identifying prevalence of certain characteristics. So if your objective of doing a study is to find the prevalence of a disease, this study is the one to utilize. They can help to take note of a risk group that may require targeted intervention for further study. Like I said, these cross-sectional studies can be used as input for future further studies. So you can be able to identify that smokers are at a higher risk, for example, or minors are at a higher risk. They provide data on multiple variables at once. That is, researchers can collect data on a number of different variables. Some of the key limitations, there are more than this, but these are the key ones. Inability to determine cause and effect. So especially if you look at the descriptive one, so it won't be able to determine the cause and effect. Even if you look at the analytical one, it will just look at correlation, but it's not definitive. It cannot give conclusive conclusions. It's got a potential for bias, so there's no mechanism for verifying the information provided, because remember, you are not following up the people, you are not going backwards. Some people may just give you the information so that they can pass the interview, or they can get it behind them. So these may be also affected by selection bias or recall bias. Some people might have forgotten what happened or how they were living in the past 2 years. They also provide a snapshot at one point in time. Thus, they cannot observe changes and trends over time. For example, if you do a cross-sectional study in winter, you may find that many people could be suffering from respiratory diseases. So you may go out there thinking that a certain exposure is causing the respiratory diseases. Unknowingly, maybe this is being caused by the common colds and flus that happen in winter. So that's another disadvantage of the cross-sectional studies. The longitudinal surveys is a way of collecting information from people or project over a period of time. So as we can see now, here's the distinction between the longitudinal and the cross-sectional. This one, it happens over months, years, or decades instead of just once. In the construction industry, especially in a company like GS Civils, which is based in the Eastern Cape, this is very useful because projects evolve over time. Worker productivity, safety behavior, equipment performance, effectiveness of training, and cost do not remain constant. A longitudinal survey will always allow you to track these changes and make informed decisions on trends rather than assumptions. So some of the key definitions, the other one is from Menard, 2002. It's a research study of change and stability over time. So the key word there being over time. And then, sorry about that. Let me just, all right. It involves collecting data from the same people or more than on more than one occasion. It allows observation of the same phenomenon over an extended period. So the key word that keeps coming up here is the period. The period is over a long period as opposed to a cross-sectional view. Key characteristics, these are time-based data collection across multiple periods, repeated measurements of the same variable. For example, you may be measuring lung capacity from year 1 to year 10 amongst the exposed employees in a mine or in a chemical manufacturing company. So you are looking at their lung capacity. Is it deteriorating or is it improving? And you are linking it to the ventilation or usage of PPE. It often involves the same participants or units. It focuses on change, trends, and development. It helps establish time order, which is important for causality. But also it's got a risk of attrition. Applications for these are further examples. So usually we look at them to look at career development, for example, aging. These are used as well for diseases like asbestos, which usually show up after 40 to 50 years after exposure. Diseases like silicosis, in a mining town, for example, you may find that there are people doing these longitudinal studies right now in towns like Rishavane or Mashawa at this present moment. Although those mines might have been closed by now, you may find that these studies are being done now. Lung cancer development is also another key data point that usually is focused on longitudinal studies. All right. Types of longitudinal studies, we look at panel studies. These follow the same individuals over time. That's according to Bryman, 2016. For example, tracking GS Civils operators on site. And then there is also a cohort study, which follows a group with shared characteristics. For example, new safety officers in the Eastern Cape. How are these safety officers performing in terms of competence or their understanding of legislation? So you look at them over a period of time. Trend study, these are studies using different samples. For example, annual safety compliance across all GS Civils sites. So this is just an illustration of the types of the longitudinal studies. So as we said, the panel studies, the cohort study, and the retrospective study. So maybe just to touch on the retrospective one, it's looking backwards. So you look at a population that was exposed to asbestos, for example, 40 years ago, and you'd like to track them and understand their current health conditions, but also taking into account their previous exposure. So that will be more on the retrospectives. So you also get the prospective one, which will look at healthy individuals at first, and then you follow them over a long period of time. That becomes a prospective. So a panel longitudinal study is a type of study that repeatedly collects data from the same group of individuals, the panel. So that's the word panel longitudinal. So the individuals are called the panel. At different points in time, this method allows researchers to observe changes, identify long-term trends, and establish potential cause and effect relationships within the same subjects over weeks, months, or even decades. The cohort studies, it is also a type of a longitudinal study, but this one follows a specific group of people who share a common characteristic or experience the same life event, such as being born in the same week, being exposed to a wartime event, being exposed to a drought period, graduating in the same year, or having a specific medical exposure over an extended time. Unlike a general panel study that might sample the whole population, a cohort study specifically targets these linked individuals to see how their shared traits influence their life trajectories or health outcomes into the future. As I mentioned, we've got the types of longitudinal. We've got retrospective and prospective longitudinal studies. The retrospective is a research design that looks back in time to examine the relationship between past exposures and current outcomes. The asbestos one in Rishavani or Mashava being a key example there. A prospective longitudinal study is forward-looking counterpart. So these are like twins, but non-identical twins. This one now is looking forward. It determines a group of people. It identifies a group of people, a cohort in the present, and follows them into the future to see what outcomes develop. So usually this one is done on healthy individuals at start, but you are now focusing on their different types of exposures. You follow them over a period of time, and then you see how it ends up. So for example, you may take healthy individuals, but some are smokers, some are not, and then you see how the smoking affects them in the long run. All right, some of the strengths and limitations of these longitudinal studies, they capture change over time. These are the strengths. They help to track changes. For example, remember the example I gave about checking respiratory health during winter. So it may give you a false outcome that says this population is suffering from respiratory issues because of the mining town close by. Yet it's just winter, but with longitudinal studies, you are able to determine if it was just a winter or it's a long-term thing. You can also identify cause-effect relationships. It's also useful for planning. It reduces recall bias. Some of the weaknesses, it's time-consuming and it's expensive. Remember, you are following individuals over time, or you are going back in time looking at health records and mining health and safety records from 40 years ago. You may need to go back into the archives. These are very expensive studies. You've got dropout issues. Some people may just decide not to participate any longer. Some people pass away, unfortunately. So this can also be affected by world changes such as COVID-19. So imagine you are doing a study and then in 2019, suddenly 2020, there's lockdown and all that. And the lockdown goes on for 2 years. Unfortunately, you won't be able to be tracking those people. Behavior changes due to being observed. So some people, for example, I'm sure all of us here as safety professionals, you know, when you say there's an audit tomorrow, people will behave differently. People will wear their PPE. People will, the environment will be clean. So people will change their behavior because they know they are being observed. There's also logistical challenges as well. If, say, someone moves from Hwange, where they were doing some activities there, and they move to Mutare, for you to be able to track that person becomes difficult. Some of the key applications, it's used mostly for safety management systems, productivity analysis, cost control, project planning, workforce development. For example, overtime tracking at GS Civils on site C260011, road construction productivity. In KZN, safety improvements after SHE interventions, equipment performance. You can also track things like effectiveness of training, so you can look at people before they are trained, what was their behavior, what was the compliance levels, and then you introduce the training, and then over time you see if there are any changes in the safety compliance or safety behavior of such people. Okay, this is just now an image that seeks to compare the cross-sectional and the longitudinal. As we can see here, the cross-sectional is only looking at a particular point in time, a specific group of people, as we can see here. It's ignoring what is happening over time. It's just looking at those people at a particular point in time. But if you jump over now to the longitudinal one, we are tracking this baby until this baby becomes an old man. So we are tracking changes over time. So this is just a diagrammatic or an image summary of what I've been talking about for clarity purposes. Also, because we like visuals, we found another one. So if you look here, cross-sectional, we are just looking at a particular point in time. We are looking at these people at a particular point in time. We ignore what happens there. We ignore what happens there. But if we look here on the longitudinal side, we are looking at that same group here. Maybe in January, we look at them again in June. We look at them again in December, or 2010, 2015, and 2020, things like that. Okay, correlational design. That's another one. We are now going to be exploring relationships between variables. So definitions of these correlational designs is Breiman defines correlational designs as the measurement of two or more variables to determine whether they are related and the nature of that relationship without any manipulation of variables. According to Skrikama, in 2024, correlational research is a type of non-experimental research in which researchers measure two or more variables and assess their relationship correlation between them without manipulation. So as you can see, these definitions speak to each other. We are looking at correlations or the link between two variables, and also we are not manipulating those variables. We are just viewing them as they are. So key characteristics: they are non-experimental, variables are not manipulated. Alternative relationships between variables are evaluated as they naturally occur. They are dynamic. Relationships between variables can change over time rather than remaining fixed. For example, if variables have a positive relationship now, that relationship can become negative in the future. These studies can also be retrospective. This type of research analyzes past data to identify trends, but it is not suited for predicting future outcomes. So this one cannot be used for prospective studies. Statistical techniques. Sorry, my slide just jumped over there. Okay, types of correlations. Think of a correlation research as a way of seeing two or more things are team players, which when one moves, does the other one move? So that's the correlation we are looking at. So if you have got two people, if the other one moves, does the other one move as well? Based on so we look at them based on different criteria. So the first criteria that we are going to look at is we are looking at the two team members or two variables based on direction. Where is it going? This is about whether the variables are moving in the same or opposite direction. So for example, on this based on direction, we can have positive correlation. They move together. If one goes up, the other one goes up as well. So it's a positive correlation. So for example, if you increase smoking, if you were smoking 1 cigarette a day, but then you increase it to 10, does it increase the number of people that are suffering now from lung-related diseases later? So we can see that smoking as a variable and lung diseases is another variable. They may have a positive correlation. A negative correlation on the other end is whereby they move in opposite direction. If one goes up, the other one goes down. For example, the more time you spend on your phone before you go to bed, the less sleep you usually get. So if you get less time on the phone, you get more time to sleep because of the blue screen and all that. That can disturb your brain. So those two, time on the phone and time to sleep, they've got a negative correlation. Then you also get others that have got no correlation at all. That is, there is no relationship at all. For example, the size of your shoes has nothing to do with your intelligence. So even if you wear size 10, it doesn't mean all people who wear size 10 are more intelligent than the people who wear size 7.
Hey.
Okay. Like I said, we like visuals in our group. They make it simpler for us to explain things. As you can see, the positive correlation, you can see if when this one moves up, this one moves up, this one moves up, they are all going up, but they are going up in the same direction. But when it comes to negative correlation, as you can see, as this one goes down, they all go down. So they've got a negative correlation, like the cell phone use and the sleeping one. Then the no correlation one that I was explaining is that if you have one variable here, the other one can appear there, the other one can appear there. they're all scattered. There's no correlation there. For example, wearing a size 10 shoe does not influence your intelligence. Okay. Just more on positive correlation. For example, exposure to silica dust and respiratory illnesses, working hours, and fatigue levels. Chemical exposure duration and health complaints. So here what we are just trying to do is give further examples of positive correlations. So exposure to silica and respiratory illness being the two variables. Chemical exposure and health complaints. Negative correlations, PPE compliance and workplace injuries. The more you use PPE, the workplace injuries may go down. There are other factors that may also cause these injuries to go down, but the more people comply with PPE, there is a negative correlation there. Safety training and accident rate as well, although we are not ignoring other factors that may contribute to a reduction in accident rate, but there is definitely a negative correlation between safety training and accident rate. Zero correlation, for example, employee marital status versus injury rate, or color of vehicle versus road traffic accident rates. So we cannot say all blue cars are more prone to accidents. There's no correlation there. There's no correlation to red cars being safer or white cars being safer in traffic. All right. These were just further examples. And then remember I said we look at the variables based on different criteria. Now we are looking at based on form. What does the shape look like? This is about how the correlations look like if we were to draw in a graph. Linear correlation, this is the relationship when the relationship is consistent. If you plotted it, you could draw a straight line through the points. For example, buying apples, if one apple cost $1, then 2 apples cost $2, and 10 apples would cost $10. So this is a linear correlation. It's a straight and steady increase. But a non-linear correlation, on the other hand, it is when the relationship changes at a certain point. It looks more like a curve or a U shape. For example, anxiety and test performance. A little bit of stress can help you focus and your performance goes up. But too much of stress can make you panic and your performance goes down. So this is more like it starts on a linear trajectory, and then the more the other one gets intensified, then it starts affecting the other one negatively. So you end up getting both the positive and negative when it's a curvilinear correlation. Just like I said, we like the visuals. This is the linear one where you can see both variables on both sides of the line there. They're climbing together, but on a non-linear one, as you can see, when the other one goes down, the other one goes down, but suddenly the curve makes a U shape because maybe when the stress becomes too much, then you can't even focus during your exams. So the relationship between variables follows a straight line representing a constant rate of change. On the non-linear one, I think I've already done justice on that one. Examples of linear correlation: test scores increase steadily as time increases. So as you start your studies, if you are doing a particular course, your test scores may be low, but as you study more on the subject, your test scores may begin to increase. The number of safety inspections and hazards identified. So the more you inspect the workplace, the more hazards you identify in the workplace. Production speed and accident rates. So the more you do the production speed, the more you tell people to hurry up, the more accidents or errors you may experience in the workplace. Non-linear correlation, heat exposure and productivity, and so on and so on. These examples, do not worry, you find them in the slides when we share them, but in the interest of time, I don't want to read everything word for word. This will be available immediately after this presentation. Then we've got also types of correlations: simple, multiple, and partial correlation. So on the simple one, as we can see there on the graph, it's more on the linear one. It looks like the linear correlation. So this is the relationship is between two variables only. So when you are looking at only two variables, for example, smoking and lung disease, or working in a chemical environment and lung cancer, you are only looking at two variables, so it becomes a simple correlation. But now, when it becomes a multiple correlation, the relationship is between one variable and several other predictors. For example, crop yield is influenced by temperature, rainfall, fertilizer, and soil type. So how much tonnage of maize you get at the end of the, after you harvest, it will be determined by the temperature, the rainfall, the fertilizer, and soil type. That's what you are seeing here in this graph here, multiple variables being affecting, multiple predictors affecting one variable. And then on the partial correlation, it analyzes the relationship between two variables while controlling for the influence of others. So this is where now you look at the other variables and then you control them and then you analyze the relationship between only two. Advantages and disadvantages. High external validity due to real-world applicability. So these are more reliable. The evidence or the data that you obtain from this is more concrete, it's solid. They enable researchers to identify and measure direction and strength of relationships between variables. They are useful for prediction once relationships are established. For example, if higher safety compliance is associated with fewer incidents, organizations can predict outcomes based on compliance levels. Useful where experimental research is unethical. So for example, you don't want to be exposing people to a certain type of a virus, or you don't want to expose people to dust. So it will be unethical. So it will be better to use the correlation of the variables. It provides a foundation for further research as it enables the creation of a hypothesis and identifies variables for experimental research. Some of the disadvantages, it cannot establish causation. So here, remember, when we started there, we said correlation. So it only looks at correlation. So it's not causation. So the fact that someone suffers lung disease in their later years while they were smoking in their 20s, it doesn't mean conclusively that the smoking caused the lung disease, but it's just a correlation. There is a relationship there. There are confounding variables may create misleading relationships. For example, a third variable problem. So there may be a third variable that you may not be aware of. For example, I mentioned that if we quickly conclude that training has reduced accident rates, that can create a problem because there could be other factors that could have caused that. Directionability problem because of lack of clarity on which variable influences the other. It depends on historical data, hence it cannot be relied on for further research. Remember, we said this one cannot be used for prospective. All right, some of the key applications on these ones, for example, in education, relationship between study habits and achievements, health, in the health sector, the link between lifestyle factors and outcomes. Economic can be utilized to examine the relationship between economic indicators such as GDP and unemployment rates. All right. Okay, now we are looking at data collection methods. Naturalistic observation. Researchers observe and record variables of interest in a natural setting without manipulation. For example, observing student behavior in a lecture to correlate with gender. Survey research. This involves collecting data related to research variables via questionnaires or interviews to evaluate correlation between the variables. For example, a survey on employees about their salaries and happiness. Archival method involves analyzing existing data sets or historical records and case studies. For instance, an examination of census data to correlate education levels to crime rates. Okay, now we move on to the next study design. It's called the causal comparative or ex post facto design. Cohen and Mannion and Marison in 2018, they defined it as a design used to explore cause and effect relationships where experimental manipulation is not ethical or where not possible. It is often referred to ex post facto. It's a Latin word for after the fact. It is a non-experimental research method used to investigate the relationship between an independent variable and a dependent variable by comparing two or more groups. The defining characteristic of this design is that the treatment or cause has already occurred. So people have already been exposed. People have already smoked the cigarettes. People have already worked in the mine. And or is a pre-existing characteristic like gender or socio-economic status, habits, exposure of past event that the researcher cannot manipulate. So the core characteristics of this ex post factor is that there is no manipulation. The researcher does not introduce a hazard or a safety protocol. They observe what is already there. Pre-existing groups, participants are categorized by existing attributes, e.g. night shift workers or day shift workers. These ones are retrospective in direction. The study looks back from a current effect. So they don't look forward, they look backwards. Remember, we said after the fact. So they may look at high injury rates to identify a prior cause, lack of mandatory safety training as an example. Application in OHS used when it is unethical or impossible to deliberately expose workers, sorry about that, expose workers to hazards. An example is comparing the long-term respiratory health of miners group A versus office workers group B. The researcher did not assign their jobs. The exposure is already after the fact. So you are not actually telling these people to go and work in a mine so that you can observe them. You find them already working there. The variables at a glance, independent variables. So remember, I think earlier on when I introduced this topic, I spoke about independent variables and dependent variables. I think it would be injustice if I don't maybe explain this further. So for example, an example of an independent variable, history of PPE use, workers who consistently wore respirators versus those who didn't. You look at shift patterns, comparisons between 12-hour rotating shifts versus 8-hour fixed shifts, or workplace culture, companies with safety first bonuses versus production first bonuses. On the dependent side of things, we look at health outcomes, incidences or silicosis or lung scarring over time, safety outcome, frequency of near-miss incidents or reactions, injury rates, total recordable incident rates. But from my own understanding is that the independent variables usually are the triggers or the causes, and the dependent variables are the end results or the effects. So that's my easy way of remembering between independent and dependent. So the dependent is caused by the independent most of the times. So key strengths, ethics first. It is the primary tool for OHS because we cannot ethically force a group of employees to work in unsafe conditions to see what happens. For example, we cannot say we are not going to issue masks to these employees that are working in a dusty environment to prove the effect of the dust or the effect of the chemicals. Also, we can, the key strength is that they are practical. They provide immediate insights from existing company data and medical records without waiting years for a new experiment to conclude. The cost is inherently cheaper as it does not require years of following up a group of people. Key limitations of this one, there's lack of control, extraneous variables, e.g. workers smoking or loud music habits. So for example, if you are monitoring lung health, you are linking it to dusty environment at work, but then after work, the employees are smoking cigarettes. You are not considering this, so you don't have control over that. For example, maybe if you are monitoring the effect of noisy equipment in the workplace, you're looking at noise-induced hearing loss, but then the employees, when they knock off, they go to the bar or the tavern where they play loud music. That can also influence that. So you don't have control over that, which might influence health outcomes. Correlation does not mean causation. So I think I mentioned this before. It can suggest a strong link, but it cannot definitely prove that only the independent variable caused the effect or caused the variable, the dependent variable. The findings are not definitive. So it's also susceptible to recall and selection bias, this ex post factor design. Other practical examples, comparing accident rates between employees who are issued with PPE and those who were not, and studying respiratory illnesses in miners versus non-miners. In conclusion, research design is the backbone of a meaningful studies. Different designs suit different goals. Cross-sectional surveys offer a quick snapshot of data. Longitudinal surveys track changes over time, and correlational designs explore relationships. And causal comparative designs examine group differences. Choosing the right design ensures reliable findings and advances knowledge in various fields. Tatenda siyabonga, bayadanki zikomo kwambiri, enkosi, asante sana. I will now hand over to my group members to field the questions. Over to you, group members.
Thank you very much, Mr. Max Mgoni. The presentation was really interesting and I really liked the visuals. Thank you very much. Can you just maybe, I didn't see the slide where you wrote the names of your group members, so maybe you can just go through them very quickly.
Okay, let me just go back to the top. So I don't know if you can see. They are
Not,
the group members.
okay, Tariro, Nganya, Tariro Moyo, Roslyn, Lerato, Gosana and Max, that's fine. Yeah, that's fine. So now you can, how many minutes are we left with? 4 minutes for question and answer session. So you can go ahead. Over to you, group 7 members. Thank you.
Good evening. Thank you for the opportunity, Doc. We'd like to take questions from the class.
It seems maybe the people are not asking questions, so can I ask one question?
Okay, ma'am, you can go ahead, ma'am.
Sorry,
okay, so my question is it possible to combine these studies, for example, the cross-sectional study with the longitudinal studies? Is it possible to combine them?
Ma'am, hello?
Sorry, can I come in while my group members are processing?
Yes, I want just to come in just.
Okay, go ahead, Nkosana.
Yes, thank you very much, Doc, for the question. From what I was, when we were busy with this presentation, with the research, I think it is very possible, ma'am, for us to combine these studies. I came across a term which is called mixed design or sequential design, whereby you combine these studies. For example, what you can do, maybe you can start with the cross-sectional study so that you understand what's happening currently, as we say that it's a snapshot. And then so that when you understand what is happening at this particular point in time, you will be able to then identify the key variables, or for example, the group of interest. Then after that, after you have identified your key variables, then you follow the selected participants. For example, maybe you identified five smokers. I'll use smokers as Max was using them a lot. So then, for example, after that, then you would follow those smokers from that group over time. So now you have shifted to the longitudinal phase. So then you observe the changes. So, for example, what I'm saying is that, ma'am, first you do a snapshot. It's 20 workers. You identify 5 smokers. Then from there, you follow those 5 smokers to observe the changes, the causes and trends. I don't know. Yeah, that's what I wanted to contribute.
Okay, thank you. I'm answered. I'm not sure if there are other people from the class who have questions.
I have no question, but just a comment to say. Is it Edson? Just to say the guys had enough time to research and to give us a good show. Thank you very much for the presentation.
Thank you. We appreciate.
Thank you very much. Appreciate it.
Thank you. I saw Lisa's hand was raised. Did she want to give a comment or ask a question? I'm not sure.
Yeah, I have a small question to ask.
Yes, you can go ahead, Lisa.
Okay. At some point, Mr. Mguni spoke about the panel study, cohort study, and the trend study. Then the next slide that I show was now talking about introspective and retrospective. Are we saying that the trend study is what is classified as the retrospective study, or it is two different studies altogether?
May you repeat your question?
Is the trend study similar to retrospective and prospective studies, or it's two different studies altogether? Yes. Move back a bit. Yeah. Okay. So it's just that when you move to the next slide, you only spoke at large about panel study and cohort studies. So I wanted to ask you, this trend study, is it what you classified? Please move to the next slide. Is it what you classified as retrospective studies, or it is two different topics altogether?
Anyone to come in before I also give my input?
Lisa, thanks for the question. I think the trend study and the retrospective study, they are different. They may be related in the sense that they both deal with time, as Max said, but they are not the same. The trend study, they are not the same. The trend study, if you check on the slide, is a type of the longitudinal design. And with this one, we check how something changes in a population or group over time. But on the retrospective study one, it looks backwards in time. So now you check your existing data or records, maybe in your company, to check the patterns or the outcomes. For example, at my workplace, maybe you can check the past injury records from, let's say, 2010 to 2011 to identify maybe factors which were leading to various workplace accidents. I don't know whether you answered. Lisa?
Yes, I'm answered. Thank you.
Thank you.
Okay.
Okay, thank you very much. I think we've already exceeded the 45 minutes by 4 minutes. So now, thank you very much, Group 7 members. We now move on to Group 10. Can they please share their slides and do the presentation? Thank you very much.
Okay, thank you, ma'am. Let me just share my screen. Okay. Good evening, Doc. Good evening.
Evening, how are you? Who is this one who is presenting? Okay, good evening. You can go ahead. All right. What's wrong, Group 10 members? We're waiting for you. Please, can you just be organized and start your presentation?
Good evening, Doc. I think he is experiencing some network glitches. Let me just try to engage him and then revert back to the group.
So if they have issues, is Group 4 ready so that maybe we can start with Group 4 while if they're resolving their problems?
Hello, Doc.
Good evening, Doc.
Doc,
Evening, how are you?
Yeah, Group 4 have asked me to flag their presentation, so I'll be doing it as and when they tell me to do so. Thank you.
Noted.
Yes,
thank you.
That is fine, Mr. Mafut. Kindly do that for us because our network has challenges here and there.
Okay, let me just do it for you.
Okay, thank you. I'm Danisa Svanda, presenting for Group 4. We are looking at data analysis in qualitative research, and we put much emphasis on thematic analysis and the ground theory. Kindly move to the next slide, sir. Yes, those are our group members. Can move to the next slide. Yes, we then try to identify qualitative data analysis in research. Qualitative data analysis encompasses a range of approaches that differ in their epistemological foundations, analytical procedures, and intended outcomes. And most widely used are content analysis, which is systematic classification of data in categories or codes. For example, in first aid, for us to give attention to the needy patients, we do have blankets where we have black blankets, red blankets, so that people will prioritize who to give care first. And also, this is not to make confusions. It can also be numbered for easy and quick identification. So also you have discourse analysis, where we examine how language constructs social reality, power, and meaning. There we have thematic analysis, grounded theory methodology. Then let's move on to the next slide. Hello, do you hear me?
Yes, I can hear you. I've moved. Unless
Okay,
you can
thank
see
Yes,
it.
we can hear you.
Okay, then
Okay,
on
thank
this
you.
one, yeah.
Yes. Then we looked at key considerations in selecting a method. A method is selected to align with whether the study aims for description, interpretation, or theory generation. It can be alignment with the research objectives and questions, ensuring the method directly addresses the study's aims and analytic focus. Consistency with the epistemological stance, e.g. interpretivist or constructivist, to maintain coherence between philosophical assumptions and analytical approach.